Hello class, this is Mr. Schweitzer. Got the homework assignment for October 1st, 2018. We're just going to be doing the front and back of the beginning of this packet. By the end of the week, you're going to be handing in the entire packet, well, by Thursday, so then you're going to have a quiz on all this stuff. This is going to be the new thing that we're learning, but the intro is just going to be a review of what we've done before. So, if you feel competent, you could go for this on your own, but if you feel stuck at any point, scan through the video and find whatever question that you need help with. So, what is the elevation of the following points? So, in order to find out the elevation of the following points, we need to find out the contour interval of this map. So, I look for, well, there's two ways to do this, really. You can look at the 1000 and the 1500, or you can take the easier route and see that this is a 900 line and this is 1000. So that makes me know that I need to go up by 100 to go from 900 to 1000. But let's just check that and make sure that 100 is a good interval. So 1000, 1100, 1200, 1300, 1400, 1500. So contour interval is 100. Since we're talking miles, something you got to know is that feet always goes with miles, and meters always goes with kilometers. So if you ever have a map that has miles on it, your contour interval is going to be in feet. If you have a map that has kilometers as your distance scale, your interval is going to be in meters for your contour interval. So let's look at the elevations. Point A. Point A is literally on a 900 line, so there's going to be 900 feet. Wait, how do you have a 900 line next to a 900 line? Turns out that off the map over here, this is going to somewhere connect back up. So it really is just going downhill to a lake, then back uphill to the top of the rock mountain, and then back downhill towards Fish Creek. So point B is on, I'm just going to follow that around. Nope, that's not the line. So it's between the 800 line and the 1000 line, right? So it's going to be, again, 900 feet. And if you follow this all the way around, it goes off the map a little bit, connects back somewhere, and then 900. So 900 feet. Point C is literally on the 1500 line, which is right there, feet. And then point D is on the 1000 line, 1000 feet. Super easy. At least it should be. So hopefully that makes sense. If it doesn't, please come in and ask me a question about it. But hopefully at this point you're confident with that. Next, we're going to calculate some gradients. We've got to calculate the gradient between C and D. The gradient formula is change in field value over distance, right? So always easiest to find distance. So you're going to need a calculator and a piece of scrap paper for this. So we're doing C to D. I'm going to first off find my distance between C and D. So I just find it on the map. I let out my scrap paper. I'm actually going to start labeling it because that's going to help us figure it out. The next part that we're going to learn, which is actually determining profiles accurately. So this is going to be a distance of 2 miles, and that goes on the bottom of my formula, so I put a line above that. And now I'm going to do the change in field value, which is the change in elevation from 1500 feet to 1000 feet. 1500 feet minus 1000 feet, and we've got to do the subtraction first on the top. So that's going to be 1500 minus 1000, which is 500 feet over 2 miles. Keep my units in there. Turn this on. So if I do 500 divided by 2, I get 250. There are my units. Feet over miles, feet over mile. You don't need the S at the end, because that just means we're going 250 feet up every 2 miles. I'm sorry, scratch that. We go 250 feet up in elevation every mile. So if we go 2 miles, we need to change 500 feet, because that's going to be doubling the amount of mileage, meaning doubling the amount of elevation. So hopefully that makes sense. I'm going to let you guys try out 3B on your own, because you're just following the same exact thing. You find the distance, and then you find the change in value. Do the subtraction for change in value, divided by your distance, and that's going to give you your gradient. So this one's going to be 250 feet per mile. I do want to see your work on that. In what direction does Fish Creek flow? A couple of you guys got this wrong on the quiz. So I find Fish Creek, and I look for those V's, right? There's a V of the line, there's a V, there's another V. And what you have to memorize is that the V's always point uphill. Now, this is a tricky one because we always think, okay, creeks and rivers and streams flow into lakes. Sometimes they actually flow out of lakes, but they all want to go towards the ocean. So the V's point uphill, which means that the stream flows downhill in the opposite direction. If you do the compass, northeast, southwest, the stream is going to be flowing this way. So if I start in the middle, I'm flowing towards the east. So it's going towards the east because of the rule of V's. What is the elevation of point X? Question 5. So there's not just one answer to this. Let's make sure that it doesn't say, okay, so sometimes they'll ask you what's the highest possible elevation. But this is just asking you what is a possible elevation of point X. So our contour interval is 100 feet. You've got to know that for this. So we go 1,000, 1,100, 1,200, 1,300, 1,400, 1,500, 1,600. So this circle here is 1,600. Anything inside this circle is going to be more than that. Anything outside that circle is going to be less. So we know that X is inside the circle, so it's got to be above 1,600. But if I had another circle on there, which there's not one, but if I add one, that would be 1,700. So you can give any elevation between 1,601 and 1,700. So I'm going to show you it this way, 1,601 feet to 1,699 feet. But since it's asking for an elevation, you can use any number. I would probably say 1,650 feet would probably be ideal, but literally anything between these two numbers works. Question 6. Now we're going to start thinking about profiles. Remember that this is a topo view here. So that's what it would be like from a helicopter. When you're doing a profile, it's what you experience in normal life when you're walking around. You see a mountain, it actually, curves up. It's hard to explain through a video, but when you look at a hill, you're seeing a profile view. You're seeing it from the side, and that's really what we want to imagine. So if we're looking from A to B, we know that the lake is going to be at the really low point. So from A, or from this 900 line to this 900 line, it's going to go down, right? And then as we go up the mountain, it's going to go higher and higher. And then it's going to go down again once we cross over this area. So what I did there was kind of made a profile on my mountain, because I know it goes down here, back up, all the way up to the top of the mountain, and then back down. So I need to look for something that goes down a little bit, back up to the top of a mountain, and then back down. So that's what I see when I look at this. Down, up to the top, back down. Let's see if we find something like that. This is a bit extreme here, and it doesn't drop back down. This doesn't show a dip in the beginning, but it's really close. And this is not far enough over to the side. So if we go down, up, and then back down, it has to be number 1. And we will learn more about that. So that's where the video is going to come in handy for question 6. Which side of Rock Mountain is the steepest? So when we're talking steepness, we are looking at the lines. So something that kids are making a lot of mistakes on that I'm seeing is they're mistaking steepness and elevation. So what I need to show you here is that if I'm looking at the side of a hill, and I'm going to curve this down a little bit more. If I'm looking at a side of a hill, this is where the highest elevation is. This is a profile view. So if I'm standing there, this is the highest elevation, right? Where's it the steepest? The steepest is over here, because if you wanted to go up here, you'd actually have to climb up it because it is so steep. So high elevation is up on the top of a mountain. Steepness is going to be wherever we have the greatest gradient, or I don't know, the steepest part, really. So where is it the steepest? Steepest will always be where the lines are closest together. That's going to be the north or the northeast side of the mountain. I'll take either answer. I like to go with the easiest one, north, and that's going to be a capital. You can write the whole word, but I like to just do a capital N, keep it simple. Which side of Rock Mountain is the gentlest slope? Well, if the steepest slope is going to be where the lines are closest together, the gentlest slope is where the lines are going to be furthest apart. So that's going to be the west side of the hill. And that's your homework assignment. That's it. So this is what we're going to be focusing on next. It's going to be drawing profiles accurately, but you really do have to understand the difference between high elevation and steepness, or high gradient.